what I'm going to be talking about today is sort of the next step in what he and I and some of the others that have been working together on this work see as perhaps the answer to some of the water wars we've been experiencing with our neighboring states, and also provide a solution for perhaps improving our water use efficiency by getting more crop per drop. So I'm going to focus on variable rate irrigation and how we can get greater value from variable rate irrigation. And it shifts the focus from the tools we've been hearing about here so far, from looking at the field as an average and managing the field as a whole, to trying to manage what happens inside the field on a better situation, because we all know we have variable soils in our fields, and all those soils can be managed differently to get higher efficiency from water use. So I know many of you have heard about variable rate irrigation. It's a technology that was developed here at UGA about 15 years ago. Now it's commercially available. All the big pivot manufacturers offer it. This little schematic here just shows you what variable rate irrigation does in case you're not familiar with it. Basically, it allows us to vary the rates of water along the length of the pipe so that we can apply different rates as we go over different parts of the landscape. So the cost of adding variable rate irrigation to your system varies from $15,000 for a very large system to up to $30,000 depending on the resolution you want and the vendor that you use. So if you don't know about this and you want to learn more, I'll be glad to talk to you about it. So I'm not going to focus on how VRI works today. I'm going to focus on how we add value to VRI. So one of the things that's very important for variable rate irrigation is to develop what we call the prescription map. So the prescription map is looking at your field and understanding the variability in the soils, and then deciding how much water you want to apply to each part of that field. So the maps that you see here, the one on the left is the initial step. Actually, this is one of Joe Boterford's fields. I don't know if Joe's in here. This is probably one of the very first prescription maps created in the whole world. So Joe sat down with us a few years ago and we looked at this field and we identified what percent of full rate he wanted to apply to different parts of the field. So you see the numbers vary from 125% where he wanted to add more water than normal to significantly less water than normal. That can then be coded into the electronic prescription map, which you see on the right, and then that is used by the pivot controller to actually change the rates. So every one of those grid cells you see on the map at the right can have a different rate, but we group them together into zones, irrigation management zones, and then the zones all get the same rate. So this is a great advance, right? I mean, it's really a huge step forward in us allowing us to address variability in the fields. But it lacks one important factor. It doesn't respond to the crop needs in those zones. So basically, we're deciding ahead of time, at the beginning of the season, or maybe once we first put the VRI on, the rates we want to use in different parts of the field. But as you know, when you have different rainfall conditions, your landscape responds differently. What was once a dry spot now becomes a wet spot because it's lower in the landscape. So what our work is focused on is trying to make the system dynamic so that the irrigation amounts we apply respond to the conditions in each one of those zones. And that's what I'm going to be focused on for part of this presentation. So here's sort of what we have achieved and what we want to make accessible to you in a year or two. This is what we envision a dashboard to be when you wake up in the morning, you check your smartphone and you're trying to decide whether you should irrigate that day or not. So you have this map of your pivot that shows up. It shows the different zones that you've delineated. And then those circles indicate locations where you've added sensors, right? So these sensors are measuring the soil moisture in those zones. That data from the soil moisture is coming to a web server somewhere in the cloud. And then on that web server is a model, could be Peanut Farm, could be another model, or Irrigator Pro, that's driving decisions about how much water you should apply. And on the left, what you see, use the pointer, it'll be a little bit better here. See the mouse? Well, it doesn't seem to want to come up. Anyway, you see on the far left, there's irrigation recommendations. That is the amount of water that the model that's running the system recommends that you apply to each zone. That information in turn gets transmitted directly to the pivot controller, and when the pivot is turned on, it's applying these rates in response to the soil moisture sensors that are in the field. This is what we call a dynamic VRI system. So to make dynamic VRI possible, we need three things. First of all, we need to have our variable rate irrigation on the farm. We need to be able to delineate our management zones adequately using a number of different techniques, and that's not an easy task. And third, we need a good soil moisture sensing system. And that's described to you now. You heard referred to it earlier in the presentation that Dr. Rabinowitz just made as the UGA-SSA. This is a system that we've developed here in-house that allows us to put soil moisture sensors in large numbers in the field. And there are two things that drive large numbers of sensors. One is the cost. They have to be cost effective. And two, they have to be easy to install, easy to remove. Actually, there's a third one. And three, they have to be wireless so that all the data streams to the cloud so you don't have to go out there and physically collect data from the sensors. So here's some photos of the system we've developed. It's based on the watermark soil moisture sensors that have been on the market for decades. What we've done is we've incorporated them into a probe, as you see in the middle picture there. And then we've created an electronics package that communicates with these sensors and sends that information wirelessly to the cloud. This particular system has been commercialized, but there are other similar systems that are available. For example, there's a vendor in the lobby right now that has a system quite similar to this that they're offering on the market. One thing I want to show you about the system is that we wanted to make, since we're putting a lot of sensors in the field, we wanted to make it easy for the farmer to go over them, right? So we don't want to have something you have to drive around continuously. So one of the big advantages here is that we have a very flexible antenna system on it, so you can go over it with a sprayer and it just bounces back up. You don't have to go around it. It doesn't have a solar panel. It runs on batteries. So it's quite easy to deal with in the field. So we put a lot of them in the field. The data all flows to a central location, which we call a base station. It goes up to the cloud, and on the cloud we have the different techniques for visualizing it. So you can see the data with your smartphone. You can go to a computer. Here's Adam McClendon, one of the farmers we're working with and whose fields we'll be talking about in a minute, checking the data in a particular field with a smartphone. So you see the smartphone is becoming a ubiquitous tool for all these irrigation scheduling tools because we know it's an easy delivery tool. So one of the cool things that we've built into this is that we have a tool on the server that converts the soil moisture data into irrigation amounts. This is a little bit different than some of the other tools that you've heard about. Most of the tools just tell you to irrigate or not to irrigate. Here we're actually recommending different amounts of water for the different zones in the field. And here you see an example from a couple of years ago from a field that we were studying. So now I want to talk to you about a couple of actual applications of this study, of this technique. This is a field that's down near Leary. It's farmed by Adam McClendon. And here we decided to do an experiment to evaluate whether this dynamic VRI that we've been discussing actually works and how it performs compared to other techniques that a high-end irrigation manager uses. In this particular case, Adam uses Irrigator Pro, the older version of the model. You'll hear newer versions in the next presentation. But this is the version of the model that uses soil temperature, air temperature, and precipitation. So we set up an experiment where we had large parallel strips in the field, and one strip was managed by dynamic VRI. The amount of irrigation was decided automatically by the sensors in our system. And the second strip, the next strip, Adam was using Irrigator Pro. And because we had VRI on this pivot, we could do all this in real time. The circles indicate the locations of sensors, so we had sensors all over this field, just not only to check what Adam was doing, but also to provide feedback to us. So here's an example of the VRI system running. You'll see images of the VRI pivot not watering non-farmed areas, but also being off over areas that didn't need irrigation at that particular time. So this is what we want to achieve, where all of this is automated and we are applying water efficiently based on real needs. So here are the results from that year. So this was 2015. As you heard earlier, we had mixed rainfall during that year. We also had a terrible harvest season, as many of you remember, because of the rains in the fall. So the yields were a little bit suppressed, but you see here on this map that we have, in the dynamic VRI zones, different amounts of water that were applied on this crop over the growing season. Now, Adam also managed each of those Irrigator Pro strips individually, so you see each Irrigator Pro strip had its own irrigation amount. Overall, the yields in the field were about the same. We averaged about the same yields regardless of which method we used to irrigate. But I want you to notice the water use efficiency of the dynamic VRI. We had about a 35% or 37% increase in water use efficiency by using the dynamic VRI system, which means we produced more crop per drop of water that we used. This could be a very important factor for the future if the water wars result in limits on how much water we can apply in different parts of the state. We repeated the experiment in 2016, okay, which was a very different sort of precipitation year. And here's sort of the layout again. And I want to show you the results in sort of more detail because we had some real interesting results. So what you see here, we had 4 sets of parallel strips again. Again, Irrigator Pro versus Dynamic VRI. You see the pairs of strips. So on this table, Uniform 1 and VRI 1 is at the top there, is one pair. Uniform 2, VRI 2 is a second pair. Look at the first box highlighted in yellow. So in each of the cases, the dynamic VRI strips use slightly less irrigation water, about 2 irrigation events less overall per season. The second highlighted yellow box is the yield difference. So Irrigator Pro, in this instance, out-yielded us by an average of about 440 pounds per acre. Okay, so Irrigator Pro outperformed us. But look at the water use efficiency. We had a 37 to 40% improvement in water use efficiency by using dynamic VRI. Now, using less water did not offset the yield losses, certainly not. I didn't even need Adam to tell me that. I could figure that out on my own. However, we have pretty good yields regardless of the method. And our next step to improve this is we're going to try and incorporate Irrigator Pro because we think Irrigator Pro offers a unique advantage. It decides irrigation events not based just on soil moisture, but also on the phenology of what's going on in the crop cycle at the particular time. For example, we think in this case, we may have missed some irrigation events with the dynamic VRI because we had adequate soil moisture, but the soil temperature at the surface may have been very high, preventing good pegging. So we may have made a mistake there. So we're going to try and incorporate both tools for the future. And you'll hear about how that's going to be done with the next presentation. So I'm going to change gears now. A lot of the information I'm telling you here is, really taking advantage of information. And one of the things that is very important to how we manage our crops is what kind of weather year we're having. You heard about this in the previous presentation. I want to take a few minutes to describe to you a great tool that's just been developed and released by Auburn University, but a lot of us have worked on it over the years. So this is an electronic book called Climate and Crops. Right now it's available for iPads, iPhones, and Macs, but it will be available in Windows platforms in the future. Let me give you a little bit of information on what it does. First of all, it has a chapter on climate. So it gives you information about how climate varies, right? So whether we have an El Nino year, La Nina year, what that means, a lot of information. This is an interactive tool. It has videos, it has photographs that expand, it has interviews with extension specialists from all 3 participating states, Georgia, Florida, and Alabama. And then it has dedicated chapters about each of the crops that are important to the Southeast, including peanuts. So the way this was done is Dr. Brenda Ortiz, who's at Auburn University, she led up this effort. She took our extension specialists from all these states, she put them in a dark room, as you can see, and she didn't let them out till she got all their knowledge. Some of them may be in this room and they can attest to that. So, for example, if you're interested in looking at peanut yields versus different climate conditions across the Southeast, you can go to each county and see on an El Nino year what happened, in a La Nina year what happened in that county. That kind of gives you an idea of what you can expect if these conditions are materializing for you. It also has a huge amount of information of what you can expect in terms of diseases, insects, other problems you may encounter based on different climatic conditions. So now you have an inventory of things you can expect and look forward to and anticipate. For example, we all know that in dry years we have problems with Aspergillus flavus, and that produces aflatoxin. So it describes the conditions that you should expect to find this occurring under. So I really encourage you to go ahead, just go to the App Store, download this. It's completely free, and take a look at it. It's really best viewed on an iPad because then you can look at all the videos and all the interactive interviews very easily. And then finally, I want to do a bit of a promotion. Many of us now have Twitter feeds where we try to provide technical information to you. And my Twitter feed is at Vellidis.group, and here I try to provide information about these developments in irrigation, developments in precision ag. Dr. Porter also has a feed that provides similar information. I'd encourage you to start following us just so you can keep up with what's going on. And as I end, I'd like to give thanks to the Georgia Peanut Commission, the Southern Peanut Research Initiative, and the Flint River Saltwater Conservation District, who we've worked with together for a number of years to develop the tools that I've described to you now. Also, the iBook was the result of a large grant from USDA NIFA. So those of you who have access to our congressional delegation, please make sure that they understand that a lot of the work we do here is completely dependent on us getting extramural funding from federal and state agencies, and we depend on that, and the work we develop for you is a result of that support.